In the previous video, we saw the origin of this equation. Kinetic energy is the mass of an object multiplied by its velocity squared divided by the number 2. So how does this help us start to learn some chemistry? Well, everything is made of matter. Chemistry is the study of matter and its changes. And the changes is the key word. Matter can undergo changes by bumping into other pieces of matter. With kinetic energy, if you move, if you bump into something, you have kinetic energy. How can I make matter move more quickly? How can I, as a chemist, make matter bump into something with a higher kinetic energy? Or how can I, as a chemist, make matter bump into other matter with a lower kinetic energy? Well, we need to look at averages. So let these funny brackets here be average of x. So if I ever put something in these funny looking brackets, it just means average. So the average kinetic energy is the mass times by the average square velocity divided by the number 2. So if you look on the average, this is proportional to the average temperature in units of Kelvin. So we've got a link now between temperature and kinetic energy, and notice that they're proportional. Notice that average kinetic energy is proportional to average temperature so long as it's in units of Kelvin. So in short, I know that molecules with mass m can collide with more kinetic energy at a higher temperature. So another way to think of this is a hot metal rod. If you look inside a hot metal rod, the metal pieces, technically atoms, but it doesn't really matter what they are, the pieces that make up the metal rod have more kinetic energy. More than what? More than the pieces in a cold metal rod. So the only difference between matter when it's hot or cold is the kinetic energy of the pieces. If there are one piece, you can make the thing hotter by giving kinetic energy to the pieces. If there are two pieces, you can make them slam into each other harder by giving them kinetic energy by heating them up. Incidentally, this is absolutely the reason why, for example, if you try and dissolve something in water, let's say it's gravy granules or instant coffee, things tend to dissolve quicker when you heat the water up. Why? It's because you're making the temperature higher, so you're giving more kinetic energy to the item that you're trying to dissolve. You're also giving more kinetic energy to the water itself. So the water and the item you're trying to dissolve hit each other harder, faster, with more energy. And this helps break up the thing that you're trying to dissolve, disperse it through the water, etc. And we can look at some detail a bit later on. So yeah.